In this lecture, we will see the schematic diagram of a transmission gate, then how to draw the twisted diagram from the normal schematic, and finally the layout. So it's a transmission gate. Now, what is the symbol of a transmission gate? The symbol of a transmission gate is, it's like this. This is the input in, this is the output out, this is the select line, that is select, and this is select bar. Now there is a control input, that is select, which is given at the gate of NMOS, and the complement of it, that is select bar, is given at the gate of PMOS. So when the select is 0, then certainly the select bar will be 1. So if select is 0, the NMOS will be on. Select is 1, then PMOS will be off. NMOS will be off when select bar is 1, then PMOS will be off. When select is equal to 1, then the select bar will be 0. So both the transistors will turn on and the input will be available at the output. So out will be equal to in. Okay. So let's see how the transmission gate is constructed. This is the symbol of the transmission gate, or you also say it as the pass transistor. This can be drawn as, this is the PMOS part, so this is the PMOS, and this is the NMOS. This is the NMOS, and this is the input select, this is the select line, select bar. Let's say this is the source, this is the drain, this is again the source and drain. The sources of PMOS and NMOS are shorted and input is applied here. The drain of the PMOS and NMOS are shorted and the output is obtained over here. So the schematic diagram is not complete because here's the select line and here's the select bar. So you have to draw a schematic diagram for the inverter. Let's see the schematic diagram of a transmission gate. This is the normal schematic. Okay. Now as discussed, we need a inverter here in order to obtain the select bar. So inverter is constructed from a PMOS and NMOS. This is the PMOS. This is the NMOS. This is connected to VDD. This is connected to ground. Let's say this is select, then the obtained output will be select bar. This is, let's say, P1, this is N1. Now, this is the source of the PMOS. This is the drain of PMOS. This is the drain of NMOS, and this is source of NMOS. These are the gates. So at this terminal, we obtain the select input, and here it is select bar. This is the output S bar. Okay. Now this is given to the transmission gate. This is the input. This is the output. Now here select bar is applied. So from here this is select bar, and the select is given from here. Okay. This is the gate terminal of the PMOS. This is P2. This is N2. So this is gate of P2, source of P2, drain of P2, source of N2, drain of N2. This is the gate terminal of N2. So this is a normal schematic diagram of a transmission gate. Now if select is equal to 0, then select bar will be equal to 1. and input can be any value like 0 or it can be 1. So when select is 0, then the transmission gate P1 will turn on, then P2 will turn off, and N1 will turn off and N2 will turn on. So in that condition, this is say VDD, this is a short circuit, then this is the open circuit, and this is connected to ground. Now from here, now the P2 PMOS is open circuit, and the N2 is connected. Here there is in, here there is out. Now let's see how to obtain the twisted schematic from the transmission gate, normal schematic. So there are two PMOS and two NMOS. So draw the two PMOS first. This is the PMOS 1. This is the PMOS 2. Then this is the NMOS 1. This is the NMOS 2. So write it as P1, P2, N1 and N2. This is the source, this is the drain, source, drain, source, drain. This is the source and this is the drain. So now you have to connect the select line. This is the select bar. This is one gate. Now this gate is connected to this gate. This is the inverter. This part is the inverter part actually. This is the inverter part. So these two gates are shorted. This is connected to VDD. The source is connected to ground. And the two drains are shorted. So if the input is select, then the output obtained will be select bar. Now this select bar is connected to this gate. and this select is connected to this key. Okay, now this is select bar. Now the sources of the transistors are shorted. The drains of the PMOS and NMOS are also shorted. So this is a twisted schematic diagram. Here you'll apply the input in from the source, and from here you get the output as out. So this is a twisted schematic diagram of a transistor, of a transmission gate. Now let's see the layout from the twisted schematic. Layout from the twisted schematic. So at first you have to design the PMOS of the transmission gate and PMOS of the inverter. Then over here this is the N-well. After drawing the now draw the N diffusion layer. The P diffusion layer for PMOS and the N diffusion layer for NMOS. And let's say this is the P diff layer. Now after drawing the P diffusion layer, now draw the N diffusion layer. On the N diff layer. Now after drawing the P diffusion and diffusion, that is after constructing the PMOS and NMOS layer, now draw the terminals. That is, this is a gate. The gate is, this is gate, source, drain, source, gate, drain, source, gate, drain, source, gate, drain. This is the inverter. So first complete the inverter. This is S. The obtained output will be S bar. So draw from this is the metal layer. This is metal 1. The source is connected to VDD. The source of PMOS is connected to VDD, and the source of the NMOS is connected to ground. Now this gate is connected with the metal, this output, that is, this is the S bar output. So this gate is connected over here, this gate is connected to here. So okay, now this gate is connected to now this is the metal layer. Now you can see there's a connection between the poly and the metal contact. You can see this region where there is poly and there is metal. So now this region needs a contact, that is the poly contact, and the poly contact is purple in color. So here this is the poly contact. When there is a connection between the metal layer and the poly layer, then you have to place a poly contact. Now this is a transmission gate. This part is a transmission gate part. The sources of the PMOS and NMOS are connected. Then the drain of the PMOS and NMOS are also connected. This is the input in. This is the input and this is the output. Okay. Now you have placed the input, output, select line. Now the only thing left is the contact. The diffusion contacts and the substrate contacts. So here there's a connection between the P diffusion layer and the metal layer. So you have to place the P diffusion contact. Similarly, over here in the P diffusion layer, have to place the P diffusion contact. This is the P diffusion contact. You can say this is the PDC contact. Similarly, you have to connect the N diffusion layer with the metal. So this is the N diffusion contact. So this is the N diffusion contact. Or the NDC contact. Now after placing the diffusion contact, you have to place the substrate contacts in the VDD and ground. So this is the N substrate contact. The contact. This is the N substrate contact. Similarly, you have to place the P substrate contact over here in the ground layer. And over here also. This is the P substrate contact. Now, or we write it as PWC or the P-well contact. So this is the whole layout of a transmission gate that is drawn from the twisted schematic diagram. Now let's see the layout from the normal schematic. From the normal schematic diagram, so in the normal schematic, the PMOS is drawn as, okay, this needs more space, so let me clear this. This is the N-well. This is the N-well of the transmission gate. Then the P diffusion, since we are constructing the PMOS. This is the P diffusion layer or the P diff layer. Then there is the N diffusion layer. Or the N diff layer. Now after drawing the PMOS and NMOS, label this as source, gate, drain. This is the drain, gate and source. So this is the inverter part of the whole transmission gate. So at first, to connect the gate, this is the gate, and the input here is the select line S. The source of the PMOS is connected to VDD with the help of the metal layer. This is VDD. Similarly, the source of the NMOS is connected to ground the drain of the PMOS and NMOS are connected, which will form the, at which we'll get the output. The output is S bar. This is the metal one. Okay. Now you have to construct the transmission gate part. This is the inverter part. So next you have to construct the transmission gate. So in the transmission gate, if you remember in the normal schematic, it was somewhat like this. This was the N well. Then the P diffusion layer. Then the N diffusion layer. N diffusion layer. This is the N diffusion layer. Now this is the, okay, let us get the terminal names. This is the source, gate and drain. These are the three terminals of the PMOS and NMOS. Gate and drain. This is also source, gate, and this is the drain terminal. After naming the terminals, now in a transmission gate, the sources of the PMOS and NMOS are shorted, at which you get the input. So short the source. This is your input in. Then short the drain. Here you obtain the output out. Okay. So now you have to connect the poly to the gate of the PMOS and NMOS. At the gate of the PMOS, select bar is connected. So okay. So we have to connect the source bar to this gate. So extend it. Connect from here. Okay. Now this is connected to S bar. So from S bar you'll connect a metal. So you can see this, at this point there is a overlapping between the metal and the poly. So we will place a poly contact. The poly contact is purple in color. So we'll draw it in purple color only. This is poly contact. Okay. Now after placing the poly contact, you can see that the select bar is connected to this gate, but this gate is connected to the select line, which is poly, and this gate is also poly. This is poly. So we do not need any contact. Okay, we can connect from here also. Okay, now here we have got select, and here is the select bar. Now you have to place the contacts here at the substrate, or at the VDD you have to place the substrate contacts. That is, in the VDD you have to place the N substrate contacts. Since here this is the N well and this P diffusion, so here this is the N substrate contact, or you can write NWC, and in the ground you have to place the P substrate contact, or you can say it's the PWC contact. So this is the P substrate contact or PWC contact. Now after placing the substrate contacts, you have to place the diffusion contact. That is a connection between the P diffusion and the metal here. So place a P diffusion contact. This is the N diffusion layer. So this is the P diffusion contact or the PDC contact. Here this is the N diffusion layer in contact with the metal layer. So this is the N diffusion contact or the NDC contact. So similarly over here we need a P diffusion contact, and here you need the N diffusion contact. This is the NDC contact. Here this is the PDC contact. So this is the layout of a transmission gate that is drawn from the normal schematic diagram. This is the inverter portion and this is the transmission gate portion.
Now let's see another form of schematic diagram of a transmission gate. This is another schematic diagram where the transmission gates won't be in twisted format. That is, the PMOS and NMOS will not be in twisted form. So let's see this schematic. Because the inverter that we have taken for constructing the transmission gate is in untwisted form, but the transmission gate, as we know that the transmission gate is always drawn like this, in this form. It's drawn like this, where this is the PMOS, this is the NMOS, this is the input, this is the output, select bar, this is a select line. So instead of this, it's is somewhat in this one of the twisted form. So here we'll draw the completely untwisted format of a transmission gate. So this is the inverter. VDD. This is the ground. This is input S. This is the output S bar. Now this we will convert to the untwisted form. So first draw like this. PMOS and the NMOS. Undo this. It will be this. So if we label this is source, drain, source, gate and gate. Similarly, this is source, drain and source. So we know that the drain and drain are connected. The source and source of the transmission gates are connected. Transmission gate, that is the PMOS and NMOS, are connected. And one of the gate is S bar. Let's say this is S bar. I could have taken a poly here. So you can see this is a metal layer, this is a poly layer. So we'll need a poly contact over here. This is a point where in the layout you'll need a poly contact. And at this gate, this gate is connected to S. It's not compulsory that this should be S, this should be S bar. These two are always complementary. That is, if this is S bar, then this should be S. So the output is obtained at the input is given at S, at the source, output is obtained at drain. So this is one form of schematic diagram. Now if you try to represent this in the layout, then you have to Keep in mind that layout should look exactly like this. Input, output, this is the select line, this is S bar, this is S. If we would have taken the second transmission gate type, that is where this is S and this is S bar, input and output, then this would have changed to something like this. We erase this line and erase this, then this S bar is connected to here, S bar is connected to this gate and S is connected to this gate. So from here we connect it's connected to this gate. So connected over here. This is S bar, this is S. This is for the second convention of the transmission gate. So we'll take the first one, or if you want we can take the second one also. So we'll take the, we won't take this, we'll take this form, okay, or else we can take the first form only. So now let's see the corresponding layout. Now let's see the layout of the transmission gate. So first you have to draw the anvil. This is the anvil, it's too big, so this was the anvil. Then we'll have the P diffusion. This is P diffusion layer. Then the N diffusion for drawing the NMOS. Okay. Now next we have to connect the gates. This is source, gate, drain, drain, gate and source. This is the inverter. Okay. This was a select line S and source was connected to VDD. This is VDD. and this source was connected to ground. The source of the PMOS is connected to VDD and the source of the MOS is connected to ground. And just make it thicker, this portion. So okay, this is ground. Now the drain of PMOS is connected to the drain of NMOS. From here you will get the output, that is S bar. Now similarly you have to construct the transmission gate part over here. This is the N1, then the P diffusion layer, then the N diffusion layer, and then this is the source, gate, drain. So this is the drain, gate and source. So the drain is connected now. This gate is connected to S bar. This is connected to S bar. So you need to place a contact over here in order to connect these two, and this is a poly contact. Okay, this is poly, then this input S is connected over here, so directly you can connect from here. So this is S. Now the sources of PMOS and NMOS in a transmission gate are connected. Just connect from here. Okay. So the source gives you the input in. You can say this is your input in. This is your output out. This is your metal 1 layer. Then you have to place the contacts over here. This P diffusion layer to be connected with the metal layer. So this is a P diffusion contact, or the PDC contact. This is the N diffusion layer to be connected with the metal. So this is the N diffusion contact, that is the NDC contact. Now you have to place the substrate contact. This is the N substrate contact since it is placed on the N well side, or N well contact. Similarly, we have to place substrate contacts in the ground layer. This is the P substrate contact, or the P well contact. So this is the layout of a transmission gate that is drawn by keeping both the inverter and the transmission gate part in untwisted form. What are the uses of transmission gate? The uses of transmission gate. Now, the transmission gate or the pass transistor is very important in order to draw any circuit. From transmission gate, it's a universal gate. It acts universal because we can draw circuits like XOR, then XNOR, and circuits like half adder, half subtractor, half subtractor, similarly full adder. Then even gates like AND, or any gate. You can draw anything from a transmission gate. You have to keep in mind the truth table of the output. If you know the truth table of the output, then from the truth table you can draw the transmission gate. By using transmission gate, you can draw a circuit. The detailed description has been given further while drawing these circuits, these gates. For example, for a half adder, the sum and the carry. Sum is A XOR B, and the carry is A and B. So the truth table for sum, that is truth table of XOR gate and truth table of AND gate, by keeping in mind these two, we have designed a transmission gate, the schematic diagram, and then the corresponding twisted schematic and the layout. Another thing in a transmission gate, you have to keep in mind always that This is the input that is given from the common source, output obtained from common drain. At the gate, the two gates are complementary. That is, if this is S, this is S bar. If this is S bar, then this should be S. We have to keep this also in mind in order to draw the further circuits.